Okay, good morning, everybody. So today's plan is to finish off the list lecture and hopefully get through part of the next list lecture. Okay, so just to remind you what a list is in Java, a list is similar to a Python list. Unfortunately, the way that you have to use it is quite different than the way that you use a Python list. Right? The way that you use a Python list is much closer to the way that you would use a Java array. Also remember, arrays are not lists though. So even though the syntax looks the same, try not to be confused between using a list and using an array. Right? Arrays are much less flexible than lists are. Okay, so another funny thing about Java's list type is that it's a parameterized type. And so it's a type where you have to specify another type. So when you use array list, you have to specify what element type do you want. So if you want an array list of string, you're supposed to say array list angle bracket string to indicate that you're of type string. Strange thing about Java lists is that you can't make a list that holds elements of primitive type. It simply doesn't work, and it's a limitation of the language. Right? So if you want to make an element of, if you want to make a list of primitive, where the elements have primitive type, you have one of the wrapper classes. So remember, every primitive type has a corresponding wrapper class. And the language tries very hard to make it transparent, tries to make it very easy for programmers to interchangeably use a big B Boolean and a little b Boolean. So for the most part, it doesn't matter which one you use. Generally, if you're using, generally if you want primitive types, you should use the primitive type because they occupy less memory and they're faster to use in terms of runtime. There is some overhead in going from a little b Boolean to a big B Boolean. If you don't worry about that sort of thing, then they're more or less, the wrapper type and the primitive type are more or less interchangeable. Except when you want to make a list of integer. So there you have to be careful about one thing. So here's an example of making an array list of integer. We're going to add the number 100 to it. Right? To get an element out of the list, you use a get method and specify the index of the element you want to get. Right? So I can repeat this process using a loop. So right here, I've got a little program called list remove. And so what in the main method, I make an list of integer. And then I'm going to add 11 elements to the list. Right? In one, like the next slide does. I'm adding 11 here because it does the same thing and it's easier to read when you print it out. Right? When I add the elements to the list, I'm going to add the elements 10, 9, 8, 7, 6, 5 down to 0 to the list. So I have a little loop here, starts counting at 10. Right? If you want to count down to 0, your condition is always I is greater than or equal to 0. Right? So as long as I is bigger than or equal to 0, do something in the loop. Right? At the end of the loop, I'm going to decrease I by 1 each time, so I minus minus, or I minus equals 1, or I equals I minus 1 as our loop update expression. Right? And then I'm just going to add the value of I to the list. Right? So remember here, we've got a list of integer, but I can safely add an int value to that list. Right? Java simply takes the int value, use the integer corresponding to I, and add that integer to the list. If we print out the list, you end up, not surprisingly, getting that list right there. Right? It's the list that has the numbers 10 down through 0 in it. Okay, so the one thing you have to watch out for when you're mixing your int with int is when you try to use remove. Right? So there we're removing, and it looks like we're trying. So here it's ambiguous. We don't know what you're trying to do here. Right? So here you might be trying to remove the number 10, right? Or you might be trying to remove the element at index 10. Right? And so just by looking at the code, in this case, it kind of looks ambiguous in this situation. And it turns out what happens here is that Java looks for a remove method, right? And it looks for a remove method where the parameter matches the type of the argument. So it's looking for a remove method that takes in an int, and it turns out there is one. right? And that version of remove removes the element at that index. And so after removing the element, right, it removes the 11th element in the list, which is the 0, right? And so it does that instead of removing the 10. If you want to remove the 10 in this case, you actually have to make an integer value that is 10, right? So if you really want to remove the 10, you have to do something like, I'm going to show you several ways to do this because there's lots of different ways to do this. Integer j equals, well, you can do it this way, do integer 10. Right. When you do that, you're going to get a warning. Notice that Eclipse strikes that out and says, hey, you probably shouldn't be doing this, right? And so it says the constructor, integer int, has been deprecated since version 9. Deprecated means that the language feature has been, you're encouraged to no longer use this language feature, and it might be removed in a future version of Java. Right? So if you ever see the term deprecated and it occurs in all programming languages, it means you're not supposed to use this feature anymore. It used to exist, and it might disappear in the future. Fortunately, it still exists, so we can still do this. So let's do it this way. And so now I can remove j, right, and then print out the list. Right, and now the 10 disappears, right, as we probably originally wanted. Okay, if you're not happy with the don't use this old feature message, you can always change how you do this. Okay, so if you write integer dot value of 10, so that's the preferred way to do it now. So the class integer has a static method called value of, right? I know it's static because I called the method using the name of the class. Right? Value of converts an int to its corresponding integer value. Right? You can do this with strings. So if you wanted to, you can call value of with a string, and we can convert the string 10 to the number 10, to the integer 10, sorry. And so this works as well. Right? So again, the 10 is gone, so that's nice. Or we can do it this, or you can just pass in the int. Right? So in this case, if you actually want to remove an object in the list, you need an object corresponding to the element, equal to the object that you want to remove. Right? Back here, 10 is not an object. And so in this case, Java finds a method that takes in an int, and it calls that version of the method. If you look at the documentation for that method, it removes the element at that index. Here we're passing in a, Here we're passing in a reference to an integer. And so Java finds the method that takes in an object, right? And it, if you read the documentation for that method, it says it removes the first object equal to the one that you passed in. Right? So now it removes the first integer equal to 10 in our list, right? And the 10 disappears from our list here. This whole problem goes away if you switch the list type to double, right? Or anything else. So if I make a list of double, right? I now can put double elements in the list. Notice here, add now complains, right? We're adding integers. Right, sorry, we're trying to add an int to our list of double. But Java refuses to convert an int to a big D double. It'll convert a little d double to a big D double, automatically convert an int to a big D double. So we have to convince it to do something like, we have to convince it to add a double value to the list. So that's one way to do it, right? Add 0.0 to I, right? That's a double. That's an int, right? You've got mixed arithmetic, so Java converts the smaller type to the bigger type. So it converts int to double, and now you get a double. Right? Don't want to add 0.0, that's fine. You can use a cast. Right? So we can say, we can ask Java to treat this integer value as though it were a double value. Right? And that also works. Right? So now if I remove the 10, so when I remove the 10 here, why don't we remove 10.0 and see what happens, like that. And now let's see what happens. So let me comment out the last one. right? And now that one does what we wanted it to do, right? It really did remove the 10.0 in this case, right? So it's gone. And so here the problem goes away when you no longer use int, right? This call here is no longer ambiguous. Right? Notice that this version here doesn't complain. Right? So here we make an integer value, an integer whose value is 10, and then we try to remove it from the list. Right? There's no error, so this will run. Right? And it seems to not do anything to the list. There's no exception. Right? And so if you look at that line, this looks a bit confusing. Right? What is that actually trying to do? So it turns out it's trying to remove the integer, it's trying to remove the first element of the list that's equal to the integer object 10, right? Because that's what we made back here on the previous slide. Right? Now this is a list of doubles, so there is no integer object equal to 10 in the list, so nothing happens. Right? But it's not an error to try to remove that. Right? Even more confusingly, perhaps, is I can try to remove the string 10 from the list. Right? And that also does not cause an error. There is no string equal to 10 in the list, so nothing gets removed. Right? Eclipse is trying to tell you something funny is happening, though. So if you hover over this line, right, it tells you you're trying to do something funny. Right? It says unlikely argument type string for remove big O object. Right? And that's true. Right? The compiler is smart enough to know this is a list of double. You're trying to remove a string. You probably don't mean to do that. But it's not an error to try to do so. In several weeks, I think, the explanation for why this actually works will become apparent to you, hopefully. Okay, so let's continue on. Here we go. All right, so I think I'm going to skip over this slide. It's useful, so, but I think it's easier to show you that information in this way. Right? So it contains all the same information, these two sets of slides. Right? It's just that the second version shows you what you would do in Python and how you can do the same thing in Java. Right? So in Python, if you want to make an empty list, and remember Python doesn't really have, the lists don't really, the element type really doesn't matter. Right? So here you can just write t equals square bracket, that makes an empty list. In Java, normally you make an array list to specify the element type. Right? And now you need a constructor. Right? So t is equal to, and then you call new. Right? You pair it with a constructor. Right? Remember, it's after the name of the constructor. Right? Remember, the name of the constructor always matches the name of the class itself. Right? So there's how you make an empty list of string. If you wanted to make an empty list of integer, you just change string to integer. Right? You wanted to make an empty list of something else, you just change that to something else. One of the common operations when working with lists is you want to check if it's empty. Right? And so this turns out to be pretty common that you do this sort of thing. The operation where empty list some way test if a list is empty. In Python, you can just write if t, right? And that's if t is empty, then the body of the if statement will run. In Java, you can't write that, right? So you always need the round brackets in Java in an if statement, right? And then the method check if a list is empty is called isEmpty, right? It's a method, so you need the round brackets to call the method. Python's got this super handy length function that works on any sequence. Java doesn't have that sort of thing. If you want the length of a list, somewhat confusingly, the method is called size. Right? So it's not called length. Right? So remember with a Java list, it's called length, but it's not a method. So you write .length, and that's all that you write. Right? If you want the size with a string, it's length, but it's methods. You have to write s.length round bracket, round bracket. With lists, it's size. So here it's t.size round bracket, round bracket. Python has an append method that lets you add or append a new element to the end of the list. Right? The corresponding method in Java is add. Right? So t.add 1, and then you pass in one value. We'll attempt to add this value to the end of the list. Right? Increasing the size of the list by 1. Right? If I have a list of string, then you can only add strings to your list. Right? So that has to be a string if you have a list of string up here. Square brackets in Python let you get a value and set a value in the list. Right? So in Java, you can't use the square bracket notation with the list. You use it with an array, but you can't use it with the list. Right? So to get an element out of the list, the method is called get. Right? The index is passed in as the argument to the method. Right? Remember, get returns a value, so you normally want to store it somewhere or at least use it immediately. So here I'm going to store it in the variable e, right? Short for element in this case. Right? To assign to an element of the list, you use set. Right? So set 0 and some string replaces the value at index 0 with the specified string. So the replace here is important. Right? So to call set, there has to be an element already there. Right? So to set the first element of the list, it replaces the first element of the list. If there is no first element, set complains. Right? So you get some sort of exception saying there is no element to replace. Right? So you have to remember, don't confuse set with add. Right? So this is one of the very common mistakes that new Java programmers make. They'll call set when they actually mean to call add. Right? Remember, add will add a new element to the end of the list. Set sets an existing element of the list. If the element doesn't exist, set complains. Right? Okay, to search a list in Python, you can just use in. Right? So if some value is in t, do something with the list. Right? To search a list in Java, the method is called contains. Right? So does t contain that value? Right? How does contain works? Well, it loops over all the elements of the list until it finds something equal to value. Right? If it finds something equal to value, then it returns true. If it visits all the elements in the list and doesn't find something equal to value, it returns false. The extend method you may or may not have seen in 121. Extend lets you add a list to another, or add the elements from another list to the current list, to t in this case. Right? So if you have another list in Java and its type matches the element type of your list, right? Then you can call add all, and that will add all the elements from another list to the end of t. Right? So if you have the list ABC and you have a second EEF, then when you call add all with the first list, adding the elements from the second list, you get A, B, C, D, E, F. Okay, so Python doesn't have that funny remove, won't get confused with that remove method. Right? Because Python doesn't let you remove by index. If you want to remove by index, you have to use the pop method. Java, unfortunately, has 2 versions of remove, which is why there's this confusion when you're working with a list of integer. Right? So pop removes the element of that index. In Java, it's remove, and you specify the index. Right? The index is 0-based and must be less than the length, the size of the list. Right? Otherwise, remove complains and throws an exception. If you've actually got an element that you want to remove from the list, then you pass in the element also with the method's also called remove. Right? So 2 versions of remove for Java lists. That's a Python slice. Fortunately, Java also has a slice, and so it's called sublist. Sublist works the exact same way as this. Yes, it does work the exact same way as a Python slice. Right? So sublist return the part of t made up of the elements starting with that index going up to, but not including. Right? So if you call sublist 1, 3, you get the elements at index 1 and index 2. And that returns another list. Now, if you're paying attention here, you'll notice that the left-hand side is a little bit funny here, right? T is an array list, right? I call sublist using T. It turns out if you try to store this in another array list, it doesn't work. I guess I should show you that. Why don't we show you that? And, oh, there's something else I forgot to tell you here. When you're working with array list, you need to import it, right? So you need to import java.util.ArrayList, right? So the reason you need to do this is because the ArrayList class, it's defined in what's called a package. Right? I haven't really told you what a package is. We'll get to that in a couple of lectures, right? It's defined in the package called java.util. This is part of the Java standard library. The rule in Java is if you are writing a class, so list remove, and you want to use another class defined in a different package, you have to import the class from that other package, right? So if you want to use ArrayList, you have to import java.util.ArrayList. Okay, so let's try slicing the list here. So I want to write, so this is what I want to write. We have a list of double now, right? So u equals t dot sublist. And so let's do 1 and 3. So I want the second and third elements out of t. Right? And notice that you get an error, right? You get a little red thing over here, which is probably hard for you. Let me see if I can make this big. There we go. Okay, notice that it's underlined in red, so that indicates that you're doing something incorrect, right? And the message that you get says type mismatch cannot convert from list to array list, right? And so something new is happening here. If you look at the sublist documentation, it doesn't say that the return type is array list, right? It says it's just something called list, like that. Right? And so it turns out, in this case, so if you actually read the sublist documentation, what it tells you is it returns the list containing the elements at index 1 and 2, right? But it returns it, it doesn't tell you what actual type of list is given back to you, right? So it doesn't say that it returns a new array list containing those values, it just says, I'm going to give you back some list. And so the type that you need to use here on the left-hand side is list, not array list. Right? List is also defined in java.util. That's important for you to remember because there's a different version of list in many different places. Right? So notice here when Eclipse says, hey, look, you can import it from here, or here, or here. There are 3 different versions of list, and you need to import the correct version. So you need to import the one from java.util. And now the error goes away. If you try to import one of the other ones, you'll end up with another error. So it's important to remember when you're working with lists, right? The package that you're working with is java.util. Okay, so the return type of sublist is not any particular kind of list. Right? Instead, it's this thing called big L list. And so I'll have more to say about big L list in 2 lectures. But for now, if you're using array list, just be aware of the fact that the return type is list, not array list. Oh, I guess I should run this. So let's print this thing out. So I'm just going to print out u. And let me, oh. Okay, so u is the list containing the values 8 and 7, right? So the part of t starting at index 1 going up to but including index 3, right? So that means starting at index 1 going to index 2. I guess I should show you sublist a little bit more while we're here. So once you've gotten u, so I've got the values 8 and 7, the question is what happens if I change u? So what happens if I remove one of the values from u? So I'm going to remove the first element from u, like that, right? Eclipse is happy with that, so it looks like this is going to work. So let's print out u again. So if you just look at that code there, hopefully it's obvious to you that we're just going to print out the list containing the 7, right? Remove the first element, so the 8 goes away. So hopefully we get the list 7. Now the question is what happens to t in this case? So when I print out t, notice that the 8 also disappears. Right? And so the way that Java's sublist method works is it actually gives you back part of the original list containing those elements. Right? So yes, u is the list 8.7, right? But it actually corresponds to the part of the original list 8.7. So if you modify u, so here we took out the 8 from u, you also take out the 8 from the original list. Right? And so you can see the 8 here is missing. Right? I don't think Python's slice does the same thing. If you modify the slice, I don't think the original list changes. In Java, if you modify the slice, the original list does change. And vice versa. List will also change. Okay. If you want to copy a list in Python, you can use copy. You can also use a slice. Sorry, I'm just going to close this door. So the copy method in Python makes a new copy of the list t. Right? In Java, there is no copy method. The way you should do it is you explicitly make a new array list. Right? So you use new constructor, right? And you tell it the list that you want to copy. So array list has a copy constructor, right? It will copy another list, right? And so that's the way you make a copy of a list in Java. The array list class doesn't have every method that you would want when working, that you can imagine that you might want when you're working with a list. So Python has a count method that lets you count the number of times the string ABC appears in the list t. Right? Java's array list class does not have a count method. Instead, you have to use a separate class to help you in this case. So there's a class called Big C Collections that works with, that has a bunch of static methods that operate on lists. One of the methods is called frequency, and so that's the method that corresponds to count. Right? Count the number of times ABC appears in the list t. Right? Similarly, with reversing a list, Python lists know how to reverse themselves. Java lists do not. You have to use the collections class and its reverse method, reversing the list t. Right? Sort is a funny one. So you can sort a list in Python by calling its sort method. In Python, you can also call the sort, so sort round brackets t. Right? They actually do two slightly different things. In Java, to sort a list, you can either use collections and call its sort method, passing it t, or in recent versions of Java, you can call the list's sort method and pass in the value null. Right? And so that's the first time that we've seen null explicitly in the course. Right? Null means no object. Right? That's exactly what it means. So you can store, if you have a variable of reference type, you can always store the value null in that variable, right? Because it means no object. So reference type, you need a reference to an object. So if you wrote string s equals null, that's fine, right? You're saying s points to or refers to no object, right? No string. And so here you have to pass in null. The reason for this is because the sort method is expecting something that knows how to compare elements. So it's expecting an object that can compare elements in your list. For a list of string or a list of double, it doesn't matter. Java knows how to compare strings and doubles, and so you can pass in null here. Right. The collections class has several methods that are often useful when working with lists. At some point, you're going to want to take a peek in that class and take a look at some of the methods. I don't recommend you do it right now because the way that class is written, you probably will be a little bit confused about what the methods look like. The syntax is a bit advanced for where we are in the course right now. Right? So there are, so that's how to use a, those are the basic methods with working with a list in Java. Do we expect you to know all of these? The answer is no, we don't expect you to know all these. Right? So for the purposes of a test, you need to know how to make a list. It would be nice if you knew how to test if it's empty or get its size. Right? You have to know how to add something to a list, how to get something from a list, and how to set something in a list. And that's more or less it. Anything else, I'll tell you how to do it. Right? So if you need to search a list, I'll tell you write a loop or use contains. Right? If you need to remove something from a list, I'll tell you to use remove, and I'll give you an example of how to use the method. Right? So remember the basic stuff. Right? Making a list, getting its size, adding, getting an element from the list, and setting an element from the list. Right? And those are the same operations corresponding to the operations that you would use. Okay, what about, so once you have a list, one of the most common things that you end up doing is that you end up iterating over the elements of the list. Right? A list is a collection of stuff, right? It's 0 or more elements. And so if you want to do something with the list, often what happens, you end up looking at the elements of the list. So how do you write a loop over a list? There's two different ways, just like with an array, right? So there's a for each loop, and there's also the counting style loop. And so this is exactly the same example that we used with an array, right? If you want to, oh no, this is slightly different. So here I have a list of string, and I would like to find the shortest string in the list, right? Assuming the list is not empty, so there's at least one string in the list. Right? So how do you solve this problem? Well, you get the first element out of the list, right? And you assume that's the shortest element. Yeah, that's the shortest string in the list, right? You remember what the length is of that shortest string, right? So remember, to get the length of a string, it's the length method. And now you loop over the elements of the list, looking at the length of every string in the list. Right? So just like in an array, you can write a for each loop. Right? So for each string s in t, right? Compare the length of the string s to the current minimum length. So remember, in the for loop, the for each loop, that s corresponds to the element in the list that we're currently looking at in this iteration. So the first time through the loop, s is the first element. Second time through the loop, s is the second element, and so on and so on and so forth. Right? When this loop ends, you'll end up with shortest, referring to the shortest element in the list. If you want to use a counting style loop, you can use a counting style loop. Right? So exact same code. With the counting style loop, I can start at the second element because we've already processed the element. The for each loop always processes the first element twice, right? Once here, once in the loop. Right? With a counting style loop, you can start at the second element, and now the code is basically the same, right? Your stopping condition is as long as our index I is less than the size of the list. Right? In the body of the loop, you have to call get to get the element from the list. Right? The for each loop basically calls get for you. Right? So it sets s every time. Underneath the hood, it's calling get to get the element from the list. Right. Here you have to call it explicitly because all I have is an index. So we get the element at index I, and away you go. Right. But they're basically the same. You could write the identical code if t was an array. Right. Sorry, not identical. Right. Get changes, size changes. But otherwise, the code would be similar. Okay, if you really want the shortest string in a list of strings, you can write a method to find the shortest string. Right? You can also take care of the case of, is this list empty? Right? So here, the first thing we check for is the list empty? Right? If the list is empty, there is no shortest string. Right? And so we're going to throw an exception in this case. Right? You might choose to do something else here. So you might choose to return null in this case. So you could alternatively say return null, right? And now the caller, when they call this method, you have to let the caller know that they might get null back as a return value, right? If there is no if the list is empty, the return value is null, right? The reason you have to warn the caller is that because you can't do anything with null, right? So if you have a reference that's null, you can't call a method with the reference, right? If you try to do it, you'll get an exception. In this case, it's probably better to throw the exception, right? To let the caller know they've called shortest incorrectly. Right? The rest of the code remains the same, right? Return the shortest, return the value of shortest at the end of the method. All right. So you can do lots of things with lists, right? Most computing problems don't involve a single object, but rather they involve a collection of objects of some kind. So another example of using a list, here we're going to try to calculate the odds of rolling two six-sided fair dice. Right, so here we'd like to know what are the odds of rolling a 2, right? What are the odds of rolling a 3? What are the odds of rolling a 12? And so on and so on and so forth. Right? If you've taken your a stats course or a probability course, you probably know how to do this already. Right? If you haven't taken a stats course or a probability course, one way to solve this problem is to just roll a bunch of dice over and over and over again and count how many times do I see a 2, right? And count how many times do I see a 3, so on and so on and so forth. You want the probability of all of these, so we need something probability of each value, right? So I need something to hold the probability of rolling a 2, something to hold the probability of rolling a 3, so on and so on and so on. You could make 11 variables, right? Call them 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But it makes more sense to use an array or a list in this case, right? And so let's write a little program that simulates the odds of rolling 2 dice. Right. The code's on the lecture slides. I'm just going to wing it, try to do it myself here. So we'll just call this 2 dice. We'll put in a main method, so public static void main string. Okay, so I need something to hold the probability for all of the different possible sums. Right, so list to hold the probabilities. Okay, so I want to list. So we only know about array list, so let's do the array list. So we'll call this odds, and that's equal to a new array list. Okay, so you type that in, Java complains, right? Why is it complaining? It's complaining it doesn't know what array list is, so we have to import it. So I can choose the first one in this case, and that'll be fine. Right. On the left-hand side, it's complaining, right? What is your array list? What is the type of element in your array list? Right. Okay, so here we've got a choice. The idea here is I'm going to count the number of times I roll a 2. So if you're counting something, you probably want. Alternatively, if you want to compute the odds, that's a real number, so you could use a list of double here. Let's do this with integer and change this to count. And then we'll deal with converting the counts to probabilities later. Right. Okay, so I want to roll 2 dice over and over and over again. Each time I want to 2, right? I want to add 1 to the count corresponding to 2 in this list. Right. Okay, so remember, they're funny. An element out of the list if it doesn't already exist, right? If I want a table of counts, all with the value 0, I have to add all of those zeros now, right? So the idea here is I'm going to make a table or a list. So here's my index for my list, right? So 0, we always start at 0. Right, 1, 2, 3, 4, 12, right? And in the list, the value that I'm going to store are the number of times we roll a 0, right? And the next one will be the number of times we roll a 1, and the next time will be the number of times we roll a 2, and so on and so on and so on, right? Obviously, the first two will always be 0. Well, that's fine, right? The rest of them, if we do everything correctly, will be non-zero by the time we're done, right? So I want to make this list, and I want to populate all of these counts with 0 to begin with. Right? So I need a loop that runs from 0 up to 12. So I is less than or equal to 12. Right? I want to add a 0 for each one of these elements. So count.add. Right? And there's my list set up holding counts of 0 for all of the possible dice values. Right? Now I want to roll a pair of dice over and over and over again. So I need another loop. Okay, how many times do we want to run? Well, we just pick some large value. So, I don't know, let's use 1,000. Right? If you don't like the magic numbers, so if you don't like the 12 and the 1,000, we can always fix that later by putting in some named constants. Right? Inside the loop, I want to roll 2 dice. Right? How do you roll 2 dice? So I need to be able to make a random number. Right? I think in assignment 1, you did have to use the random class. So it looks like that's what we're going to do again this time. So outside the loop, I'm going to make a random number generator. Right? And so if you remember from assignment 1, the class that generates random numbers is called random. Right? I'm going to call it RNG, short for random number generator. Right? Random is a reference type. Right? So in other words, I want to make a object of type random, which is new, right? And a constructor to make the random object. Right? Notice again, Java complains it doesn't know what random is. It turns out random is also in Java util, so we have to import it. Right? So there's our import statement for random. Right? Okay, so inside the loop it's easy. I want to roll a 6-sided I want to simulate rolling a 6-sided die. Right? So int roll. Okay, so I want RNG to make a random number. Right? I want a random number between 1 and 6 inclusive. Right? If you look at that method there, you probably can't read its documentation. But that method there, nextInt, returns a value between 0 and bound -1. Right? So I can make a random number between 0 and something, but there is, at least on my computer, there is no method that makes a number between some lower bound and some upper bound. It turns out there is one, but I think I'm using an older version of Java here. Right? So I want to make a random number between 1 and 6. The trick here is to make a random number between 0 and 5. Right, which is what nextInt 6 does. Right? So how does that help me? Well, I've got a number between 0 and 5. If I want a number between 1 and 6, I can just add 1 to the random number. So after the brackets plus 1, right? So nextInt, random number between 0 and 5, add 1, random number between 1 and 6, and away you go. Right? I want to do that twice. So I guess I want roll 1 and roll 2. Oh, sorry. Same thing, like that. Compute the sum. Right? So there's my sum. So I now want to go into my table. So suppose I rolled a 3. Right? I want to go look at the current value for what's there, because I want to add 1 to this. Right? So the current value is stored in my list. Right? My list is called count, so I want to get whatever is stored at the index sum. Right? I want to add 1 marker right? Because I just rolled another value equal to sum. I just rolled another value equal to sum, and I want to put it back in the list, right? So to put it back in the list, that's set, right? So I want to set the sum, right? And the new sum is now cur plus 1, like that, right? And so that simulates rolling 2 dice, computing their sum, right? And then updating the list, right? Adding 1 to the current number of times that I've rolled sum. Right? All right, so let's run that and print out the list at the end. So let's see what we get. Count. And there's our list, right? So we saw 0 times, makes sense. I can't roll 0 with 2 dice. I saw 1 0 times, also makes sense. I can't roll 1 with 2 dice, right? And I saw 2 27 times, I saw 12 25 times, and so on. The 160 corresponds to the 7, which turns out is the most likely value that you can roll with 2 dice. How do you compute the odds? Well, I just take all of these values and divide by the number of times that we rolled the 2 dice. Right? So that gives you an estimate of the odds. So let's do that. Now, if I want to divide all the values by the number of times I rolled, so divide everything by 1,000, I need a loop. Right? So here's our loop. Okay, I don't care about 0 and 1, right? Because I can't roll 0 or 1 with 2 dice. So let's start at 2. I know that there's 12 values in the list. So I can go, I can run the loop as long as I is less than or equal to 12. Sorry, not, yes, 12, that's right. Okay, so go into the list, ask for the element at index I. So so C is going to be my count. I can't call it count because I already have a variable called count. So that's going to be count.getI. Right, so that's the number of times I rolled a 2 and a 3 and a 4 and so on and so on and so forth. Right, take the count, divide it by 1,000 and print it out. So let's do that. System.out print line C divided by 1,000. Right. When you do this, the first thing you should, whenever you see something like this, right, the first question you should ask yourself is, what are the types of C and 1,000? So they're both ints, right? That's an int, that's an int, right? The value of the count has to be less than 1,000 because I rolled the dice 1,000 times, right? So it's either 1,000 or it's less than 1,000. So if I take an int that's less than 1,000 and divided by 1,000, I get back the int 0, right? And so this, not surprisingly, prints out all zeros, which is not what I want, right? What I want is I want to compute the division as a real number. So I have to convince Java that C is a double or 1,000 is a double. So in this case, it's easiest just to write 1,000.0 and now run it. Right, that's better. So these are in percentages. Right? So the odds of rolling a 2 is roughly 0.035%. The odds of rolling a 7 is roughly 16%, right? And the odds of rolling a 12, roughly 2.7%. I actually, oh yes, here it is, right? And so if you look at the actual, right, they correspond, they're close to, but not exactly equal to these, right? If you perform the simulation more times, so if you run this 1,000,000 times, like that, right? The computed, and divide by 1,000,000 here. Why don't I divide by 10,000? And this will give us the odds in readable percentages, right? You'll see that the percentage odds become closer and closer and closer to the theoretical odds, right? And that's one of the things that happens when you run a simulation involving random values. Right? Typically, you must run the simulation many times to accurately simulate the process that you are trying to model. Right? All right, so we're out of time. We'll look at another example of rolling dice or something in the next lecture, and we'll do some recursion in the next lecture as well.